fellow scientists. My name is Jesse, and I'm a member of the Saskatchewan Science Centre's Go Science Outreach team. Today, we are going to make a rocket fly 100 feet in the air. And it isn't going to be hard, like rocket science or something like that. This is going to be rocket science. Today, our rocket is going to be powered by pressure. Now, pressure is the force exerted on an object or an area by something else. So, for example, when you press down on a table, you're putting pressure onto it. Or, here's another example. If you went really deep into the ocean, the deeper and deeper that you go, the more and more pressure the water puts onto you. Now, to make our rockets launch today, we're going to be adding a little bit of water, and then we're going to add some pressure. When that pressure gets released, it's going to push down on all of that water, which is going to create a lot of force and send our rocket flying. Let's do a small-scale example to learn how to make it work. This small container right here is called a film canister. Now, a long, long time ago, when dinosaurs roamed the earth, well, not that long ago, about 30 years ago, these containers were used to keep camera film, which is where the photos were saved, safe. Now, the really important thing about these canisters is that they seal extremely well. And a tight seal is very important to help us build and hold pressure. Now, to make it work, we're going to be adding a little bit of water to this container, and then we're going to make it build pressure by adding a piece of something called an Alka-Seltzer. An Alka-Seltzer is one of those little fizzy tablets that help you when you maybe have a headache or a stomach ache. When that Alka-Seltzer goes in, it's going to start fizzing. That fizzing is going to create our pressure. If we put the lid on, that pressure is going to start building inside of this container, and eventually it needs to go somewhere. We're going to flip it upside down, and when we flip it upside down, it's going to push down and send our rocket flying. Let's see this rocket in action. All right. So, first what we're going to do is we're going to fill our canister with a little bit of water. We don't want it to be too full. We only want it about 1/3 full. Next, we're going to take a little chunk of Alka-Seltzer. That's all we really need right there. We're going to drop it inside. Get rid of the extra Alka-Seltzer, put it in the pocket for now. Put the lid on top. Give it a little good shake. And let's see what happens. That rocket was cool. But I said we would launch a rocket 100 feet in the air. And to do that, we're going to need a bigger container and much more pressure. Also, because we don't have a room that's 100 feet tall in the Science Center, we probably should head outside. All right, to scale this up, what we're going to do is we're going to use that 2-liter pop bottle. We have that pop bottle about 1/3 full of water. That's going to allow us to build up a lot more pressure, and having that water is going to allow us to be able to get more force, which will send our rocket flying further. To make that pressure, we're going to use that bike pump that's back there, and that bike pump is going to allow us to get to a high pressure more consistently. The last thing that we have is that orange platform over there. That's our aquapod platform. And that's going to be what allows us to be able to actually launch this rocket into the air. Let's go see what happens. Okay, we're at full capacity. Are you ready? All right. 3, just a sec. All right. 3, 2, 1. All right, well, that rocket was awesome. We managed to get it to launch super far by adding all that extra pressure and making all that extra force with that bigger bottle. Now, I hope you had fun learning about rockets and launching some rockets with us today. If you want to check out some other really cool experiments, you should head on over to SaskScienceCenter.com and clicking on the Real Science, Real Fun online button. All right, well, until next time, stay curious, fellow scientists.
Hello everyone, my name is Sally Science, and I love it when you send in your curious questions for us to explore together. And today, I have an awesome question from my good friend Brixton. Take it away, Brixton!
Sally Science, why is the sky blue?
Thanks for sending in that question, Brixton. I'm super excited. I also bet that you're not the only little boy who's wondering why the sky is blue. So would you believe me if I told you that the sky is blue because it's reflecting the color of the oceans? Ha! Well, you shouldn't, because that's not the right answer. Although a lot of people thought that was the answer for a really long time. Fun fact, if the oceans suddenly all disappeared off the planet Earth, the sky would still look blue. Well, to humans anyways. But how cool is that? Okay, in order to get to the bottom of this mystery, we have to learn about 3 things: light, molecules, and our eyes. Would you believe me if I told you that the light that you see from the sun is actually made up of all the colors of the rainbow? It's true! Scientists call this the light spectrum. And what is really, really cool about the light spectrum is that each color looks like a wavy line. And some of those colors of light have really big spaces between their waves. And some of those colors of light, like blue light, have much smaller, tighter waves. Can you see in my rainbow how short and tight together the blue and purple arches are compared to, say, the big yellow wavy ones or the red ones? How awesome is that? Okay, next we have to learn about the molecules in our atmosphere. Ha! Those molecules, hey, we seem to talk about those teeny guys a lot. Anyways, atmosphere is a big fancy word that scientists use to talk about all the air around us and all the air around the planet Earth. And the atmosphere is made up of different gases like oxygen and nitrogen. And those gases are made up of, you guessed it, molecules! Okay, so here is the crazy part. When the light from the sun reaches the atmosphere of the Earth, the colors of light bump into those different molecules and cause light to scatter in all kinds of directions, depending on how big their waves are. And blue and violet light waves scatter faster and wider than any other color of light because their waves are so much smaller. And this bumping and this scattering of light waves and molecules is one of the main reasons we see the sky as blue. Another fun fact, because the molecules in the atmosphere on the planet Mars are different, the sky looks different. On Mars, during the day, the sky looks orange. And at night, it looks kind of gray and not blue at all. How super cool is that? But our eyes and our brain play a big part too. In our human eyes, we have things called rods. And rods are the reason that we get to see color. And when we look at something, The rods in our eyes send a message to our brain, and our brain decides what shapes and colors we see. How super cool is that? Truthfully, there are more violet light waves buzzing around us than there are blue light waves. But because our brain can interpret blue light waves easier, we see the sky as blue and not violet. Pretty neat, hey? Fun fact, dogs don't have as many rods in their eyes as we do, and so they don't even really see as many colors as we do. So the sky to a dog probably looks kind of gray and not blue at all. Thanks so much, Brixton, for sending me this awesome question. If you have a question that you'd like to explore with me, please send it to me. I would love to hear it. Take care, friends, and I hope you get outside to enjoy the blue sky. This is Sally Science, signing off.
Hey, how you doing? Tommy Tungsten here for Elements R Us with another super special sale. The reviews for today's product have been positively glowing. Phosphorus. This stuff is highly reactive and is guaranteed to ignite your interest. You may have even seen it around the house as those red tips on the end of matches that help them light on fire. Not only that, phosphorus is an important mineral nutrient required by all living things. Don't go eating them match heads though, kids. You can find all the phosphorus you need in the foods you already enjoy, like meat, dairy, eggs, and grains. All the ingredients to a nice carbonara, huh? So you need to eat this stuff, but guess what? Plants need it too. They use it to buff up those stems and convert them sun rays into pure energy, which is why it's a main ingredient in fertilizers. It's always in demand, and you are not going to find a more explosive deal on a powerhouse like this. So come on down to Elements R Us and purchase up a supply of phosphorus. And when you get there, tell them Tommy sent you. Capiche?